this video, we'll define absolute max and min, define local max and min, and identify extreme values. This is the 4.1 pre-class video. Alright, let's start with the definition of absolute maximum and minimum. You probably have a sense of the meaning of these words, but we're going to state the definition rigorously here. So let C be a number in the domain D of a function f, then f evaluated at C is the absolute maximum value of f on D if f of C is greater than or equal to f of x for all x in D, right? It's saying f evaluated at C is greater than or equal to all function values. F of C is the absolute minimum value of f on D if f of C is less than or equal to f of x for all x in D, right? If f evaluated at C is less than or equal to all of our function values, now we need to distinguish absolute maximum and minimum from local maximum and minimum. So the number f of C is the local maximum value of f if f of C is greater than or equal to f of x when x is near C. So the main difference is we're looking at when x is near C, we're not looking at all x in our domain. That is, we're looking in the local neighborhood around the number C. And likewise, the number f of C is the local minimum value of f if f of C is less than or equal to f of x when x is near C. So not all x in the domain, but just when x is near C. Alright, let's look at a graph to get a visual example. The domain of this graph is the closed interval from a to f. We have an absolute maximum value at f. That's because our function evaluated at f is greater than or equal to, but in this case it looks like it's just greater than, all the function values at all x in our domain. And we have an absolute minimum at a, and that's because f evaluated at a is less than or equal to f of x for all x in our domain. Next we have a local maximum at b, and that's because f of b is greater than or equal to f of x near the number b. Near the number b means if you go a little bit to the left of b and a little bit to the right of b, and we look at that interval containing b, then we say f of b is greater than or equal to the function values on that little interval containing b. We also have a local maximum at d for the same reasons why we have a local maximum at b. At c there's a local minimum because the function evaluated at c is less than or equal to the function values near c, right? If you go a little bit to the left of c and a little bit to the right of c, then f of c is less than or equal to all those function values in that interval. And likewise, at e, there's a local minimum. Alright, one last thing to note is all these absolute and local maximum minimums are called extreme values. So if you want to talk about all of them in the plural form, we use the word extreme values. Now finding these extreme values of this function on this domain from a to f wasn't too bad, but let's look at a tougher graph. So here we go. Our domain on this graph is from a to e, although it's not including a. Just notice there's a hole or removable discontinuity at a. And our absolute maximum is at c. That's because f of c is greater than or equal to all f of x for x in our domain. And on this graph, there's actually no absolute minimum. If you try to state what the minimum was, well, you might want to say f of a, but our function is not defined to a, right? There's a hole at a. A is not in our domain. Well, then you might say, what about the numbers right next to a? Well, you could always get closer to a and get a function value less than the previous one. All right, next we have a local maximum at c, and that's because even though there's a jump there, f of c is greater than or equal to f of x when x is near c. Right, if you go a little bit to the left of c and a little bit to the right of c, f of c is greater than or equal to all those function values in that little interval containing c. All right, and at d, there's a local minimum, and that's because f of d is less than or equal to f of x when x is near d. Well, that's it for extreme values, but you might be wondering, what about at the numbers b and e? Well, at b, that's not a local maximum or minimum, because if you go a little bit to the left of b, you have function values that are less than f of b. If you go a little bit to the right of b, you have function values that are greater than f of b. So any open interval that you put around the number b, you'll have function values greater than and less than f of b. And then at e, we don't call that a local maximum. So that's not a local maximum, because to be a local maximum or a local minimum, we always have to put like this open interval around our number, in this case around our number e. So you can only go a little bit to the left of e, but we can't go a little bit to the right of e because our domain ends at e. So we don't consider endpoints of our domain to be local max or local mins. Well, that's it for this video. Hopefully this warmed you up for class on section 4.1.